Hi, my name's Michelle Farrell. I work with IES out of Europe, even though I have a very American accent. Came from Boston. Just to talk about, just to kind of wrap up this healing tools concept, is that in your model, you're going to have a lot of holes. And these holes can come from things like the wall center lines do not line up, room separation lines are blocking other pieces of your model. And what we've tried to do with this is say, we're going to fill in those holes for you. And we've made a decision that if the hole is smaller than 1 square meter, then that's going to become an opaque surface or a wall or roof. And if it's vertical, and it will fill in as a window if it's larger than that. On the roof, it's going to find ways to resolve connection points between your walls. Because in Revit, sometimes you're going to have things like drains or everything that can really cause the roof to be very confused. Changing slant of it. And what this is trying to do is come up with the way to actually bound that room and not have to look at all those roof slants and triangulation. One thing when you're looking at your model for import, you can see on this upper model here, all of this triangulation that's happening. This is something that we've worked to resolve a lot. Because even though it's actually bounding your room and shutting your room, every time you add a surface in VE, you're adding time for your calculation. Even if you have a rectangular box or a cube and it has a lot of triangulation on it, the way that the calculation engine works is that it's constantly checking each surface. And it's just going to cause another reference point or kind of a ping point that it bounces off during that analysis. And as Sarah said as well, with the shading surfaces, if you bring in something on a complex shading surface level, you're talking about maybe 1,200 shading surfaces. You have things like 6-sided 2 centimeter or 1 inch mullions that are coming through. Does that really matter to an early stage energy analysis or even to your full energy analysis in the end? You don't want to consider that. It's making the calculation take too long and it's insignificant information to what you're working on. However, if you're doing a daylighting view and you say, I really want to see these in this one room, that's when you're going to choose to import it in using that level of complexity. So what we've really dealt with in this is that I'm from an architectural background, so I understand where architects are coming from, is that you have Revit, you have the ability to add all of this detail, but then you also have on the engineering side the desire to have a model that's shut, that's sealed, that's going to come through very well, and is going to not have any holes. So inherently, the softwares are kind of working in different directions. It's not going to be perfect yet. And I think that's the biggest thing to realize. The issues that you're dealing with are not something that only your firm is dealing with. And there isn't a firm that says, me and my engineer are working 100% perfectly together. That just isn't the case yet. There's improvements on our end with things like the healing tools. There's improvements inside of Revit. Every year they're working more and more to improve that export. But then you might get a model from Vectorworks or ArchiCAD, and it's going to look completely different because right now it's not a fully standardized language. And so it's about, let's try to decide, how do we clean this model up? Do we have enough information that we're getting from it? Educating an architect that you're working with, which is extremely important. That architect has to have in mind that they're going to use this model for analysis from the beginning. If you take a model that's been completed, that they have not thought of analysis until the moment they give it to you, and they have built it the way that they may build it with layered walls and these room separation lines, it may take you longer to clean up that model than it's going to take you to redraw it. And I'm sure that's the case of what you've run into. So what you have to say to your architect is that there's the opportunity for us to collaborate earlier, to collaborate in a better way, but we have to follow these rules. Architects kind of ran into the same thing when they started doing 3-dimensional rendering. And doing these, you had to figure out your layers for your materials. And this is just really another part of that evolution of the industry to say we have to do things a little bit differently and think of analysis earlier. But there are benefits for this, as Sarah was saying, where this model may not be completely done. You know, I mean, we don't even have doors, we don't have a lot of detail, but in this case, I've actually included 3 design options. This is a great tool if you're working with architects to start off really early. You can set up 3 sets of design options. In this case, we have slightly different square footage, slightly different glazing ratios, and whichever one is going to be primary is going to be the one that's going to export. So you could say, give me 3 design options that you're looking at in the same file, cleaning it up once, and when you export it, I can set the different ones to primary. But don't be afraid to tell your architect that if you want me to do less work, if you want me to bill you less for this endless cleaning up, then read this paper, you know, the paper that we put out, and that this is going to help make that translation a lot smoother. As Sarah also said, detach from central. That's extremely important because there's often a lot of traffic on the network, as anyone who's in IT knows. There might be 5, 10 people digging into the model for whatever reasons. That has to be done. Also, if you're running into problems with your model, always try saving it to the C drive before you export. It could be that you have something weird in the character path that's causing an issue during the export. Of course, drop it right back on the network because IT will hate me for saying to save anything onto your main computer. But often, sometimes just doing that, you'll see that it's an issue with something that's happening, or a character, or even something like a money symbol in a path can cause these types of things to happen. You'll also notice that in this drawing, I don't have much in here. I mean, I don't have furniture, I don't have stairs, because you don't need that. What I would do if I got this model, let's say one of you sent it in, and I'm sure I've seen at least 1 or 2 of your models that have come in. I'm going to highlight this whole thing, and I can't see it right now because it's very small. Well, the resolution's off. But I highlight the whole thing, and I'm going to go to filter, and I'm going to get rid of everything that I don't want on this model. I can often reduce the file size of this model by 50%. So if you're sending me a 100 megabyte file, I can get it down to 50, usually. I'm going to get rid of line work, extra views, 3D pieces that are in there that I just don't necessarily need. Cameras, line work, I mean, you know the amount of stuff. Light switches on the wall, these types of things. I mean, the amount of detail, I have to say, is truly amazing that you can put in the drawings, but it just causes it to take longer. Why it does that? I mean, it excludes this information, but it has to go through when it runs through that export. And it has to check every item, like, okay, we have this baluster for this. Is this an item we need for analysis? No. So it runs through and checks that out. So if you have 4,000 of these, you can imagine that during that run, that's going to take a lot of time to check every piece. Often crashing the computer in the meantime, and then never getting it exported. So then there's also the architects who say, why would we ever touch a BIM model like this? All the information is supposed to be inside of it. The reason that we have originally done this is because everything can exist in the same file, and it's all going to work perfectly. And unfortunately, at this point, I would say that one of the largest architecture firms in the US that I work with, very heavy users of Revit, right now they keep 2 parallel models. They're going to keep their model that goes to construction drawings, and then they have a model that's schematic or at the conception stage. Once they hit design development, they keep that simple model, which is often like something like this. Obviously, you might have doors and different entities in here, but just keep it very basic. And if you've tried to clean up a Revit model, you'll know that you adjusting this to increase the square footage or can increase the floor to ceiling height once is going to be a lot quicker than going in and saying, oh, where are these rooms intersecting? What's happening here? So they have found, because they have both engineers and architects, they can control that process. And they think it's actually quicker to keep a simplified model. So that's their solution at this point. Another thing that's interesting from that is you'll see Autodesk has a new tool called Vasari. And this tool is actually a much more simplified type of model specifically for energy analysis. And that can come out also as a GBXML. So you can actually take the shell of a Vasari model. If you have something that's a construction document model that's just not going to come out, you can pick your external walls and use that. But I think just in showing that they have developed that tool, they also understand that the complexity of a construction drawing model is often something that's just too heavy for analysis. So some of the things that Sarah had mentioned was that you're looking at these entities here like these jogs in the wall. Okay, so if we're going in and we're going to do a SIBC analysis on this for heating and cooling loads, we want to run through and run this. And we have these jog walls. This could potentially be a half wall, or there could just be a sink back here. This is not necessarily going to severely impact all of your analysis. So you have to decide that this entity, when it runs through this room, is going to become a shading surface. So it's not actually even being thought of as a thermal wall, because it's not bounding anything. It's just kind of a jog. Because you know the virtual environment, this would actually be its own room. Then you would have holes here and here if it was going to be two walls and then an opening. So these become shading surfaces. So you have a decision. Do I want this to become an individual room on its own and add a room separation line? Or do I just want to ignore these? And in most cases, you're just going to ignore them. So I'll just select them here. And then this is really your key, is this room bounding. Room bounding is going to save you a lot of this mess. And now when I unclick room bounding, it's ignoring those elements. So it's a way of keeping them in your model, but without having to delete them, because you certainly don't want to go through a model and delete every column. You can delete stairs, you can delete line work. I mean, that stuff, it's okay if you're going to use an energy analysis model, but you're not going to want to delete columns, because some of them might actually be part of a wall causing that room bounding element. So I think the biggest thing to realize with, let me just look, if I go home, when we go to room and area and volume computations, when you have a very large model, you're always going to want to open this up, and you'll see that areas only is often left on, because when it's doing an area and volume computation, every time you zoom in and out of your model, you're rerunning that volume computation. So if you're looking at a 3D view, that's going to cause it to run really slow. So a lot of people, architects you deal with, are going to put this on areas. So when you open it and you see that there's an issue, doesn't look right, make sure it's turned on here. This room and area computation is actually quite deceiving, because this purely means the way that it looks at it when defining things like tenant space or other details inside of Revit for its takeoffs. But in reality, it's always coming from the center line of a wall. So that means, like in here, if I have this wall, so these are two walls that are the same. It's coming from the center line. So this wall actually will jog on the exterior surface of my wall because I'm following the center line. What happened before is we would actually get a hole here because there was no wall coming in. But if you have a lot of conditions, say you have a conference room where that occurs 10 times to just show that there's a bump out in the wall detail, you're actually ending up with 1, 2, 3, 4, 5 surfaces every time this is occurring. So if you add that to something like a more realistic building that we're doing, like 100,000 of square feet, you now have so many additional surfaces in your project. And also an adjacent room may intersect with it in a weird way because the adjacent space doesn't really understand why that's happening. So what I have in my model is everything is just changed to being the same. So if you can have it the same, and this is why we say save off before you go into design development, when you're just drawing the basic model, where you're not saying, oh, all right, well, in this wall, we want it to go like this slightly. It doesn't matter at this stage. The next thing I'm going to show you here, which is very common, which was the walls layered next to each other, because people want to show things like wall core having different layers. Some firms make it their practice to have people build like the gypsum layer and then the insulation and all of it on actual separate walls, and that will cause a huge issue. Another problem we had a while ago, and I've been out of the design side for a while, so I don't know if it's been solved in Revit, but when people would layer floors on top of a large floor slab, and the reason for this was the inability to add different finishes to separate floors. So you might have a very thin floor in here that shows there's carpet in this space and this room has tile. So in doing that, you can actually hide hundreds of rooms underneath this, in between these two. There might be a millimeter gap, and you may not know why all these rooms are layered on top of each other. So any of the layering, it doesn't work. I mean, think of the way that it is in VE. It's one layer at a time. It's going to be the model itself. So if I just go to this view. The other thing that I'd like to say is when we turn on, have our room heights set. You just turn on the graphics to show interior fill. Okay. So when I grab this room, I'm going to zoom in here. And you can see that my room is tied to a height. This height is extremely important because when you think of the way a room fills a space, you almost think of it as like you're dumping water in it and it has to be tight. And that water has to be bound by the rim of this room. And it has to know that when it comes up to this level, this floor slab is actually bounding it. That means that if I had tied this room height to here, it would actually think it's ending here, it's not intersecting a floor, and there's a hole on top of this space. So I have to tell it by saying this is actually tied to the height above by tying it to a level. So it's, in a way, it's a little weird like that. And what some architects do as well is they'll tie it to a height. So they'll say, okay, I understand that. So I'm tying it to 14 feet instead of to this level. So when they tie it to 14 feet, what will happen is that someone comes in, the budget's been cut, the ceilings are now 12 feet. They're going to go in and change this to 12 feet, that's okay. But if they come in and the budget increases to 16 feet, it's locked to 14 feet. So now you have a gap of 2 feet inside of this model that's going to become exposed to the exterior. So there's so best practice on this is to say upper limit is going to be the level above. And it's a good way to keep that in practice. Another question that we had actually yesterday was Revit MEP versus Revit architecture. Why are these two different? And not sure, probably many of you know this already, but I'll just go over it quickly. Architecture, our plugin will export rooms. When you're in Revit MEP, we export spaces. When you're in Revit MEP, you will see all the rooms, but they're not going to come out no matter what you do. It just will always take spaces. And someone asked, is Revit ever going to standardize this? No, they're not, because the reason for having these different is that as engineers, you may treat an entire office or tenant space as one zone, where the architect is going to treat this as a closet, a copier area, a waiting area, a coffee break area, all these different spaces that the engineer may say, I want this to be one volume. I don't want this to be more than one. So you can have as many rooms as you want. You don't have to delete them out, but they will be ignored inside of Revit MEP. So it's all about where you're taking it out of. So again, with the varying size walls, sometimes I'll also do with your models, if I get them, I will just try to highlight all the interior walls and change them to the same. It doesn't usually work so well because it'll gap the walls sometimes, but it is a way to try to start cleaning it up. Also, here the column issue. You can select the type if you want and edit the type to be non-room bounding, or you can just select in a view using filter, which is probably my best thing, which is actually over here, but we can't see it due to issues with resolution. That's definitely a way to fix it. Another thing that will also occur this type. As Sarah said, you're going to have issues with holes inside of your model, making it external. So let me minimize this just to show if I can find it. Okay. So here's those conditions and what we see how they actually come through as. So if I was to leave those external walls that were layered, and those were actually, okay, that was going to be the wall bumping out where they were layered. It's actually just going to come through as a shading surface. If I was going to leave those columns, now I have a room that actually goes along a few feet, comes in a foot, jogs another foot across, goes out, and then is flat. And it simply has a shading surface across it. So not only is this an inaccurate representation of the room volume, but it's going to cause the calculation to take a lot longer, which is a big problem. Because some things like this may be really nominal in the calculation numbers, but if this adds an extra 3 hours to your run, or you have this occurring in 200 places, this really starts to destroy the runtime of your model, and it almost becomes unusable. The other thing you see is this is a, I believe, medium level, kind of medium-low level of complexity. And we don't have the 6-sided mullions, but we still do show where they are. Meaning that the windows are actually cut. So these are 4 different individual window panes with wall between them. So the other thing is just adding a kind of perpendicular shading surface that intersects it. So is that really necessary? How much is that really impacting my building? This is more than good enough to use for daylighting analysis. The other thing that Sarah had mentioned is adding constructions. We have a lot that are done here. If you're an engineer, you're probably building your own, so you're not going to use these. If you're an architect, you will use these for early stage analysis. But I think one of the biggest questions I get is, why would I do that? I've already done the constructions of my building in Revit or in Revit MEP. And the issue is inside of the virtual environment, when you actually have your model and you have your constructions. Let me bring up the construction templates. Inside of Revit, even if you have a detail added to your wall like an R value or a U value, it doesn't contain this information like conductivity, density, specific heat capacity. So that's actually missing. And until that information is added, which I actually hope will be added to Revit MEP at some point, not yet, but when that is added, that's a construction we can use. But at this point, it's not detailed enough to actually use and to bring in the VE. So that's why when you come in and you're like, where's all the stuff I added? It's not there because it's not part of the GBXML scheme. And actually, that information isn't even exported from Revit at this point. So we're kind of at a position where we're reassigning constructions. But you'll also see that if you're using Vasari. You're reassigning constructions through that. Yeah, just one other thing on the things like dropped ceilings. As I mentioned, anything that intersects this volume will stop it. So if I have a dropped ceiling, or if I have, say I have a shelf in a room, and I made that shelf out of a floor element just because it worked well for my design, and I decided to have that stick out. If I actually go to the view, and that was coming out, and I had a shelf coming out here, this room volume would be stopped by it. So now it's going to start to cut in my space. So don't just think of making things non-room bounding that are in kind of your horizontal views or your plan views, but also in your vertical in the space. Because you get that a lot with like acoustical ceiling tiles that people drop in and those types of issues. Another thing that will cause problems is overlapping your window frames. So if you have a lot of windows along an edge, like this model does, your best bet, like here, for these windows, rather than take a bunch of windows that look similar and layer them together and kind of arrange them so they appear to look the right way, I'm going to want to edit a window family and actually change the window itself so it fits properly, and it's going to come through a lot better. Because when you start overlapping frames of windows, they're going to start cutting and causing issues with clipping the surfaces. We did add a fix for this. It used to be a big problem where it would cause errors, and the fix will actually cut them, but they're not going to line up and they won't look correct. Another thing with doors, if we have doors in a curtain wall, like right here, I have a door, this is not going to come through. What it is it's just an edited plane, and it doesn't actually come through. But there is kind of a good trick with, let me see if I can grab it from this view. If you grab this pane itself, you can go in, and if you change it to opaque, so I could go in and change this to an opaque panel. I could actually make part of my curtain wall a solid wall, and I could make part of it glazing. So say we had a very tall building that's 10 stories high, and at the edge of the building, maybe where the floor intersected, I wanted a 5-foot area that was going to be a solid wall. What I would do would be grid my curtain wall, like perhaps this bottom area would be the solid, grid my curtain wall and make it solid, rather than stack walls on top of each other. 100% of the time, that's going to make it translate much better. Because anytime you can use one wall instead of stacked walls, it's much cleaner. The reason for this is that when you stack your walls, no matter how much you try, somewhere your center lines are not going to be completely perfect. So as you go up those 10 stories, they may actually be off ever so slightly, which will cause issues with your volume. And when you translate it through, you'll see that there might be gaps in the floor. And anytime there is a gap, you're adding more surfaces for analysis, and it has to fill it in, and it has to do these types of things. So we do recommend that if you have a curtain wall, if you can, go all the way from the bottom floor to the top floor, choosing your opaque panels to represent solid walls rather than stacking. But that is a hard one with architects, because that is a very common way of doing it, especially for cutting through with your constructions, because you obviously this wall would not just be a panel and a curtain wall. It might be a steel frame wall with more detail to it. So that is one of the issues with it. Finally, just to go over external holes. A very common thing you'll see for architects often is if you have a porch or an atrium space or something that is a covered area, there'll be a room inside of it. And what they do with it is, instead of having a window here, you have something like an opening, these are all windows, but just an opening in the space. So what a hard thing to resolve with this is IES does not have external holes. This is immediately going to stop any Apache Sim run or any MacroFlow run. And we are going to talk about a way to check this before it gets to the point of analysis, but there's a lot of people who will be working on their model for weeks and not notice this until they get to the point of analysis. And then all of a sudden you ran it at night and it's not working. So you want to check this ahead of time. But for those spaces, you basically just want to get rid of the room and make them external, because they're not actually an external space. They're a porch, they become a shading surface, or it's an atrium, and you don't need to have that defined as a room, because Revit will allow you to define it as a room, which is completely in opposition with the way that IES defines it. And for many of those openings, they sometimes will be filled in as windows, or they'll be filled in as a wall, but it will really depend on where it is, how big it is, and where it's positioned. So going in and cleaning those up and deleting rooms from any external spaces You'll also see that a lot of architects will miss a lot of rooms, like that space here on the side. So this is where we had, it's on one of these sides. Yeah, this space is where I had that little jog coming in. And that was not defined as a room. It could just be a mechanical shaft or whatever. A lot of architects also build their columns like this by showing a bump out in the wall. And those need to be treated either as non-room bounding, or there needs to be a space put in it as an unoccupied space. So you can really decide which way you want to handle it. There's also a lot of decisions on how to treat drop ceilings, how to set those up. And you can either ignore them and then set them in the VE if you want by dropping the height, copying up, and adding another space. You can treat it as one zone or a zone over each room. Or you can put in a reference level and reference level plane there and set it up and drop a room inside of it. And we have instructions on how to do that we can give you via email. But dealing with drop ceilings inside of here can often be messy, especially if they're all at different heights. They're all in different, a lot of detail added to them. Sometimes they don't come through very easily. So you'll have to see the condition of it and make the decision if you want to pull it from Revit or work on that yourself.
There's a lot of, I suppose you could term them workarounds. And that's the situation that we're in at the moment. We're totally upfront about that. In the audience, you might be thinking, well, why don't we just sort it out in the software? Why is it not that easy to just get the software to fix all these things? And I mean, I would justify that at this point in time by saying that we use GBXML. I mean, okay, that might not be the best way to effect that exchange between the two, but that is what we use currently. The other issue, which Michelle kind of touched on, was the fact that there's no standard approach in how people use these BIM tools. So you've got complete flexibility to build that model in any way you see fit. You can use walls to be roofs or whatever you want to do. And we can't legislate for all of those possibilities using the GBXML import, because it is fairly simplistic in the way that it deals with things. I think with the acceleration that I mentioned earlier in the UK and the uptake of BIM, that we will start to see a more standardised approach, because one of the things about these BIM models is that they will have to be usable in different downstream applications. That's the whole point. You create that model with all the information in it for maintenance throughout the whole building life cycle, for asset management, and that's one of the key advantages of it. So that there is going to have to be some rules and some standardised approaches will be set out for people that want to be able to exploit this fully on their projects, and we will be able to take advantage of that. We are dabbling with IFC, for those that know anything about IFC. So that will be something that will be available in the future. It might cause, because of its sort of the more comprehensive nature of IFC over sort of GBXML, completely worlds apart in terms of what they can understand and be used to exchange. So with that comes potentially more problems, but equally it may be something that is easier for us to manage. So this is all early stage. I will still keep saying that. Although we've had the functionality in there now for quite some time, it's still fairly early days for this sort of integration. Yeah.
And the other thing I would add to that, with IFC through Europe, we've also seen that there's a desire to create a much more standardized approach to IFC, being that Green Building XML was originally developed for a particular program, so it's very specific to particular companies that use it. So with IFC, it's much more open source. You see a lot of governments in Europe, using that. So that is something that maybe in the future is also going to be a lot better. The other thing I would say is that if you have consistent problems and you keep thinking, if this was only better, I could do so much more. But you have to tell us. Otherwise, we're not going to know. And we do take in every Revit model. We do look at it. We do take it into consideration of how we can improve things. And also, I would suggest to send it to your BIM vendor as well, because that's the way that they're going to understand how engineers are using it. So any questions you have, you can copy both of us on it, and it'll help improve it. I think that sometimes you underestimate how much impact you have on the development of software, but there are teams of people both with us and at Autodesk and at SketchUp, and they all want to know how to work with energy better. And so big impacts.
Yeah, I mean, in the UK we have the right drivers now, so it is bringing the institutions together, and obviously the major design firms as well are getting involved in trying to make this work. So, and we're involved in that as well. When Michelle was going through the rooms versus spaces and the ceiling voids and all that, there wasn't much kind of like nodding or anything. Did that sort of thing make sense? Is this the sort of thing that people are finding?
I think part of it is educating the architect. The other part is understanding how to query the model. So a way that I look at it is that if I have a model that's, let's say, 10 rooms, and only one of the rooms is giving me a problem, I know in IES I can delete that room, redraw it, see if it works. If I get a model that's 10 rooms and 9 out of 10 rooms are a problem, it's probably going to be better if I start over. So it's all about the quality that you're starting with. So you can, I think, feel very free to go back to an architect and say, this is unusable for what I'm doing. And also provide them documentation on why. Not just from us, but also there's the same documentation produced by Revit and other programs, and say, you know, make these little edits to it and we'll see if we can get a little further. But if they learn how to do it, works better. But I'm going to show you in the second session some ways to query your model inside of IES so that you can see, are there external holes, are there problems that are going to be causing me issues later, and those types of things. So there is a check that you can do that you really should be doing. But often what you'll see is that, like, if one of these rooms is causing me a problem, what I'll do is just go in and say, that room, I'm deleting it. And often when you run this model check, you'll see that it's all the rooms surrounding it that have errors, because when you have an intersection error, the intersection error is the room itself and the room adjacent. So if you actually go through and kind of print out the floor plan and check it, you'll see it's all the rooms around it and then that room. So you'll realize it is only one room that may be causing a problem. So that's one way to start to query if it's those pieces of your model or not.
Is the Revit model and the GBM XML limited to the geometry? Does it cover other things such as occupancy, room set points, structures you've mentioned?
Right. At this point, it does not, and that's it's part of the inherent way that it's coming out of the GBXML. I think that it's going to probably happen in MEP first to pull that information out and to be able to get the occupancy in those details. But right now it is purely a geometry thing. And that's why when you assign something using our toolbar like office to it, that's where we're getting our occupancy from, our heating and cooling set points, all of these details. So I completely understand that that's unfortunate at this point, because you do put all of that information in. But what happens is when you assign that to a room, it simply becomes text inside of a spreadsheet. And it's not really something active that comes out yet. But like Sarah had said, when this starts to become more standardized and all the BIM tools will provide it as output in the same way, more tools can take that in. And also some people hope that IFC will be maybe the leader in that too, in taking some of that out. And then also putting it back.
Yeah. I mean, it's something that we are looking at, is how we can bring more information across. I mean, the materials, you know, we have discussions, and again, with a more standardised approach than that, we would possibly be able to use even just, you know, materials names, tags sort of thing, to tie into what we've got in the VE. So that you'd still have to sort of maybe refine it a bit, but essentially it's bringing across something from in terms of constructions and materials.
Yeah, like with that, we're like saying, you know, if you have named all your walls generic wall 1, then that will become a wall category inside of VE that you can then apply a material to. So that's the type of thing that we're looking at right now, since the construction details are not detailed enough for us. But then that would be easier, you know, then you can just apply by category type of thing. So that's part of what we're looking at.
Yeah, but meanwhile you've got 20 people building new wall, this wall, red wall, whatever, you know, it's just too much. And then you've got different packages doing different things as well.
Things like ducts and piping and plumbing fixtures and all of those types of things are ignored by the GBXML. So it's just like having furniture in your file, that it would be one of those things I would probably highlight and delete out at the beginning, because it is just going to take longer and it makes the file a lot bigger. Another one that's extremely big when you set electrical is photometric details that exist in your file that may be tied to luminaire fixtures. And those are huge, so those are something you also want to get rid of. But if you do have photometric files attached to your Revit model, you can't pull them in directly, but you can use that photometric information and pull it in through LightPro or import it into the VE. So it is usable.
I mean, what I will say, just in response to the first question as well, was we have been running some workshops with design teams, really getting to the bottom of this on their particular projects. And a lot of once you iron out the issues with what we've talked about, so having the right room heights and, you know, so the volumes being calculated, all that sort of thing is nailed, then the uncertainty from what I can gather to date really stems from the engineers not necessarily trusting that model that's come through to do their calculations on, which is fair enough, because they're going to be responsible for what the calculations, the results of those. There's always going to have to be a measure of checking that geometry, checking the adjacencies in the virtual environment. You know, there'll be some cases where, I mean, we had an example a couple of weeks ago where we had a walkway which had slanted walls, and it was actually, because of the way that the volumetric calculation was done in Revit architecture, it was taking the volume as being sort of straight up. So it was cutting out a sliver of room on either side of this walkway. And what that meant was when you came into the VE, those walls were external, because there was nothing in that little V shape. And that was something that was relatively quick and easy to then rectify in the virtual environment. But there's no getting away from the fact that, and Michelle will cover it in the second session, that you'll have to check the geometry that comes in. When it's early stage, it's not going to be so much of an issue, but where you are doing your Part L calculations or something, it's got to be right, and that is your responsibility as an engineer to make sure it is.
Just wanted, I'm an IES user, and
Thanks.
I often find most time-consuming part is building the facade.
Mm-hmm.
Is there any way to just import the facade to IES?
I mean, you could import the shell of the building, absolutely. It would require there are ways to select a lot of things inside of Revit and possibly make them
Because I mean,
not come through, but it's not, the problem is everything is an individual room. So it looks at these as all of individual room volumes. So really, the best way to do that.
I mean, I just thought if you could select the facade in such a way, say, these are only windows and the rest is the wall.
Yeah.
And then import that shell to IES and then create your room within that shell.
Right.
You can build rooms within the shell using the partition
No, absolutely,
tool,
but
it's a bit of a clumsy way to do it.
Yeah, the issue is that because there's 100 individual rooms inside of here, you would first have to get rid of all of the internal spaces, all of the internal floors and internal walls, delete all the rooms, then kind of close the shell. But one way you can, when you're in Revit, if you go to your views, so if I go to a front view or a side view, and I go to export, I can export a DXF in a 2D plan if I want to trace that image. And there's actually on our website, there's a good video that shows how to take a 2D DXF and trace it onto a shell and then stamp it onto your building, basically. You basically draw it on an adjacent space and then put it adjacent to your rooms. It kind of stamps it on there, then you delete the space. So that's one way, and if you want to just take facade, that would probably be the quickest way, is pulling them out. But remember that you always have this option too to take out DXFs. Kind of defeats the purpose, but if you're trying to get specifics for overhangs or mullions or something, then it is a way to pull that out. But definitely, it's on YouTube, I think, that video. And it shows how to create facades quickly.
Yeah.
And not have to do it on an individual room, but do it in a whole building level by looking at just a facade in the background.
Thank you.
Bye.